Hey, hi everyone. I hope everyone is doing well and is really enjoying the content on product managed. So today, basically, we are going to look at strings and stacks, and this is more like a technical topic. If you remember, we have covered list and its operations, then advanced list operations, then data structure called trees, heaps, graphs. So we are covering strings and stacks in continuation of that particular topic. I think you can revisit, I think, those topics in any sequence. These are all independent of one another, so there's no need to follow any sequence. Just pick up a topic, learn about it, and then I'm going to tell you like how do you actually go ahead and solve out for the questions. I'm soon going to start, I think, coding from a software engineering perspective as well, which means basically the kind of questions that you can expect in software engineering side, because there's been a lot of demand that I've been getting through Telegram, Slack, and a lot of other channels, and folks have requested that I should cover that as well. So give me some time. I think you'll soon see, I think, those. So without further delay, I think let's get into strings and its introduction. So what are strings? Strings are basically a type of data, right? Data types, and they're typically represented as arrays, correct? Of bytes, where you can either have a word or a group of words, correct? That store a sequence of characters in a memory. So, and then strings are defined as an array of characters, correct? The typical differentiation is between this and array could be like, string is terminated with a special character, right? So do remember that strings will always have this backslash zero, right? So now coming to strings in Python and its operations, right? So what are some of the operations as we saw in list, right? There are certain kind of operations that you can do in Python. There are obviously a bunch of other languages also, but for the purpose of my discussions, I'm usually going to focus on Python. What are the reasons for using Python? Widely used language, most compatible, I think. Um, Probably easy to learn as well. So that's why Python is picked up. So looking at the operations and string types in Python, so string literals, right? I mean, strings can be defined using your single quotes. You can use double quotes also, or you could use triple quotes also. The difference between single and double quotes is obviously that single quotes don't allow for variable names to be included in the string, while with double quotes, you can also include the variable names, right? So big distinction. Single quotes is just like a plain simple set of words, right? But you can't include variables. So if you have a variable name also in your string, right? So let's say for example you are saying happy birthday and name, and the name is something, let's say you pass it in a function, happy birthday Varun or happy birthday Aditya, right? So you are recursively sending out, let's say, on different dates, right? So based on that variable name, you can replace the name. That's allowed only in double quotes, right? Triple quotes are used for doc strings, not treated as raw strings. Barely used, I think. Haven't used a lot, right? String concatenations, I think name suggests, when you're trying to concatenate two strings, you can use the plus operator here, right? We'll look at some examples. String slicing, subset of characters, for example, or subset of words also, right? You specify the starting position, which is always going to be zero, or it could be one, two, three, four, also, whatever, depending on your. And then you say how many characters you want. So in this case, for example, hello world zero double this thing colon, and then uh, five, right? So this is the extraction of world hello. String indexing can be indexed, as you know, right? Zero. It starts with zero, right? I mean, that's the important part. Remember that. There are a lot of string methods, do operations such as you can convert everything in your screen to uppercase, lowercase, replace a word, find a character, format it, right? I mean, do read about it in the official Python document. And how do you actually remember this? I think it's more around practice. Like if you start practicing coding questions, I think you'll get it. Like there's no need to mug up Python, these form methods, I would say. Once you start, let's say, solving 50 to 100 questions, right? I mean, you'll know that I think these are maybe the most commonly used methods, right? So string formatting, again, for my name is, for example, dot format. So what this is doing is it's giving some sort of a format, and you use the percentage operator. So variables, as I had mentioned, right? So my name is blah 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 dot format John. Correct. Remember double quotes. Obviously, you can pass the variable name. So here, for example, you're saying that you apply a format to the variable name, and you are also calling a piece of string before that, like characters. My name is, and then you're providing whatever format you want, right? So here, for example, you're saying that John is a string basically, and you're saying that my name is John, right? String comparison, straightforward. Can be used to use equal to, is not equal to, greater than, less than, etc. etc. String conversion, right? You can convert these to integers, floats, booleans using the int, float, and bool functions, right? So now coming to the examples in strings, right? What are some of the, like, this is more to give you an idea of how, you can get started in Python. So concatenation of two string, I usually pick up one easy example and one difficult example. If there is no easy example, I'm definitely going to pick up one difficult example, and by difficult I mean, like, there'll be like two or three different concepts involved. Right? You might have to go through it again, right? So concatenation of two strings, fairly straightforward. I define one string, I define another string. I am calling the third string as string one plus string two. Correct? Straightforward, right? I print the string and then I get I am there and here. Correct? Now, let's say there is another example that I'm considering, probably like a medium or a hard difficulty. I want to find out all the duplicate characters in a string, right? Let's say I have a string that I pass, so I want to find out duplicate characters there, right? So how do I do that? Essentially, I'll have to define a function because it's going to be recursive. I define let's say, a dictionary. What is a dictionary? We'll cover that. It's not extensive as, let's say, some of the other data types, but just imagine, like, it's a collection of similar, like, let's say, objects. Right. So here, for example, it could be collection of words. Correct. So that's what it is. We define an empty dictionary. Now we are iterating to each character in the string, correct? Now, whatever your string, like, I mean, that will pass. I'm iterating through each of the characters. So for char in string, I'm using a for loop here. Uh, and if char is not in chars, so what is a chars? Basically, the first time it is an empty dictionary, correct? And if you are not able to find, so basically this step is initializing the dictionary, right? So you're saying that if character is not in chars, which is the character in the string that you're looking at, if that is not found here, then you initiate it, right? Else, if the character is already there in the dictionary, you're just incrementing the count, right? Straightforward logic. Create a list, obviously, that you want to store the duplicate character. So again, you have defined an array, and you're saying that duplicates is equal to, right? You are going to copy the content in this list, correct? This duplicates list, correct? Now you're iterating through the dictionary to find the characters that have a count greater than one, right? So remember, we first iterated through all of. So what we see here is that when you're iterating through the dictionary, correct? Then you are basically looking at characters that have a count greater than one, right? So this is the logic that is built here, and then you're basically returning the duplicates. So if you try it out and pass a string like "Hello, how are you?" then you are going to get H, which is repeated twice, E, L, and O, right? So every duplicate character, is basically returned out, right, as the outcome. So, with that, we basically come to the end of strings as data type. Now, coming to stacks, right? I mean, those are another type of data structures, correct? And these data structures, basically, stacks kind of follow the last in first out principle, right? So what it means is that whatever last element that you added to the data structure, that remains on the top, and that is also the first one to be removed, correct? They are obviously used for a lot of applications that we'll see, but one of the most commonly used ones are undo and redo functionality, parsing and evaluation of expressions. I think this one you might have actually seen a lot in a lot of applications. I'll cover the applications, but start thinking about the real practical examples as well, right? uh, Obviously, you need to maintain the pointer to the top of the stack, correct? And the last element to be inserted, because we can access the elements only on the top of the stack, right? That the pointer is necessary from that perspective. So now I'm coming to this part wherein, for example, we started, let's say, with just 2 and 3 in the stack. Then you push one, right? One becomes on the top. This top is basically the pointer. And then you do a 2 and 3 here, for example, and you do a pop operation, right? So pop will take out the top operator, the top element, right, in the stack. And then top is also changed to now point to the next element in the stack, right? So this is an important part to remember. What are some of the stack operations? As we saw, I think for list there were certain operations. For stack also there are pop, push, top is empty, and size, each providing you a functionality so that you don't have to write out the function yourself, right? I mean, these are functions, and there are many more operations, I think, might be less used, right, in stack. I would suggest go to the official Python doc and, like, figure out, I think, a way to just glimpse through it. You don't have to necessarily remember. My philosophy is very simple. When you start solving the problems, if you do get, I think, stuck at some point, refer to those, and then once you know, I think, make a note of it that this was some new function that you learned about stack. Keep a note of it and move on. Application of stacks, I think, as I mentioned, right, important to express evaluations. For example, you might have an expression, right? You can use stack to actually evaluate what is that, expression. There's a lot of documentation on infix, profix, postfix comparison. You can go through it. I'll probably cover in some later, like, video about how do you actually solve problems using that. But from a product management perspective, not as important. Parenthesis matching, yeah, I mean, you can match out parentheses, using stacks. When I say it is not important, it is not important from a product management interview perspective. It is definitely maybe important from a software engineering, depending on which round you are in, right? So coming to the third application and my favorite application, which is the undo and the redo functionality. So stacks can be used to implement undo and redo functionality in applications, right? Uh, if you want to, let's say, undo something, right, which is your Control Z button, right? It's nothing but implementing the stack. So in companies like Firefox or Chrome or any other browser related companies where you're interviewing, expect, I think, some question on this. Also, I think photoshopping, where I think you have Control Z, right? So each, let's say, meta element of a photo, right, could be pushed on top of a stack. You remove it, which is basically a Control Z operation, right? So forward and backward features in web browsers also implemented using stacks, right? Now, I think backtracking is something which is, what happens usually in backtracking algorithms is that you start off with a list of elements, and the algorithm, let's say, is a fixed logic that is given to you. You keep on, like, I think, keep on putting the elements one by one, and then you are looking at which element basically leads to a, let's say, a dead end, and you basically stop, right? So we can discuss more about it, but let's say, you had an algorithm where you're trying to find the maybe the most optimal number of combinations, right? Given different list of numbers, right, that need to be used. It could be, let's say, identifying weights of a regression algorithm, for that matter, right? So instead of trying out, let's say, all the possible combinations of weight, let's say you are saying that given a condition like my, uh, let's say, my error rate is reaching whatever beyond certain threshold, I should stop. So when in that case you're using stack elements to pass the weights, and then you will stop at certain point where your number is of the error threshold is reached, right? So that is one way of backtracking, where you're not calculating the weights themselves, but you are basically backtracking the weights. You have given certain possibilities by using different combinations of it, and you stop at one, basically, right? Implementing recursion, yes, recursive algorithms, there is a separate topic altogether on it, but when its task is to be performed, where, you're storing function calls and their parameters, stacks are very useful. Implementing hash tables, yes, but hash tables can also be implemented in any, like, many other ways. Here, for example, you're looking at hash tables, the key and the values, correct? And you're retrieving them using a hash function. Dynamic programming implementation, not seen a lot, but basically, you are storing intermediate results and reusing them instead of recalculating them each time. Right? It could be any, like, intermediate function outcome, for example. Now, bunch of, I think, algorithms that can be implemented using stacks like factorial, Fibonacci, binary, Nuth algorithm. Factorial, as you know, is basically multiplication, right? 2 factorial is 1 into 2, 3 factorial is 1, 2, 3, right? Fibonacci is, instead of multiplication, it is sum, correct? And binary search, you can, like, obviously store the search range and then keep on dividing it in half until your target element is found, right? And the Newt's algorithm, basically a longest common subsequence of two strings, correct? So I think where is this useful is uh, more, I think, software engineering side, definitely. In product management interviews, if you're interviewing with a software engineer and if you have implemented, let's say, your search on a product using binary search, feel free to flaunt it. Feel free to talk about it as much as you want. This is probably the only discussion that you're going to have on it, not beyond that. Right. So now coming to the examples, right? I have always told you that I believe in taking one simple example and one hard example. But for stack, I think we are keeping it like, let's say a medium to probably a hard level category of example. So here we want to reverse word orders in a string, correct? Now you define a function, you start with an empty list, then you are going to traverse the given string, right? And the logic is that until you see a space, basically, you keep on appending the string characters, correct? So this is the string that we had started with an initial this thing. We are iterating, and until we have found like a blank character, we are keep on appending it, right? When we see a space, we basically print the contents of the stack, correct? So this will work, I think, for all the part where this logic, right? The last word, for example, might not have a space, might have a space, might not have a space, but that's an edge case that you have to look for. So when the length of the string is greater than, so here we are using the length of the string, right? Concept which will tell you that what is the total length of the string, right? Until it is greater than zero, keep on printing, the the element which is last but one, and obviously look at also the space, right? And then do a pop operation. So remember, pop operation, for example, removes an element from the stack, right? So what it will do is that it will keep on so for this one, right, you keep on, let's say, traversing the string because the string length is going to be there, which is greater than zero, and then you keep on coming to the second last part, which would be not the space, right? And then you pop out the elements, right? So which means that you are removing the element from the stack, which is the space, correct? And then you are doing the main function call, correct? So for example, I pass the string as hello there, and this is, even though my last, I think, item, I have deliberately given a space, and here you see the outcome. If you were to pass the string as hello there with no space also, then also the outcome will be the same. You can go ahead and check it out. So I hope, I think, this lecture, this video was useful. We covered two important topics, strings and stacks. Do go through, I think, the video, and do leave comments if you have any doubts or need any clarification on any of the topics. We are soon going to cover queues, recursion, sort, and then we'll jump on to some of the advanced algorithms. These are more like, I would say, software engineering questions. If you watch these videos, I'm pretty sure that at least one round you'll be able to clear for software engineering as well, along with product management in companies like Google, Meta, where there is definitely an emphasis on these topics. So until next time, stay tuned and do like and subscribe the content.